Here's the answer for day 3, problem 1. Find all real zeros of this polynomial function. To find the zeros of this function, we need to set the function equal to 0. So it would look like this. This creates a polynomial equation a lot like the bellwork from just the other day. Let's try factoring method. This trinomial will factor into a binomial times binomial. X times x is x squared. And how about 3 times 10 is 30 because 3 and 10 add up to 13. Then we can solve for x within both of these factors. Within the first factor, x turns out to be negative 3. And within the other factor, the x turns out to be negative 10. These solutions for x are called zeros to the polynomial function because if you input them for x, that function outputs 0. Day 3, problem 2. Sketch the graph of f of x equals 1 plus log base 3 of x. We're going to graph this by plotting some points and then drawing a line through the points. This is a base 3 logarithm. Let's substitute numbers for x that are wise numbers to use when you have a base 3 logarithm. One number that's good to put in for the variable whenever you have a logarithm is to put in 1. 3 to what power makes 1? 3 to the 0 power is 1. So this portion of the function turns out to be 0. And then we have this additional plus 1 in the beginning. 0 plus 1 is 1. So function f equals 1 when we used 1 for x. So 1 comma 1 is on our graph. For a base 3 logarithm, another good number to use for x is 3. 3 to what power makes 3? And that power is 1. So this logarithm part of the function turns out to be 1. And then when you add 1, you get 2. So when x is 3, the function value is 2. 3 comma 2 is on the graph. When the base is 3, another good number to use for x is 9. 3 to what power makes 9? Well, 3 to the second power is 9. So this log part turns out to be a 2. And then when you add 1 to it, you get 3. So when x is 9, the function value is 3. 9 comma 3 is on the graph. When we sketch the log function in, we want to draw up close to the y-axis without touching the y-axis. Something like this.